Okay, again for access control methodology, some definite things to take in consideration are, of course, basics of access control is you're trying to prevent things from happening either through whitelist or blacklist. Does everybody remember what whitelisting is? Whitelisting is, yes, it's a trusted list, and then the blacklist are the ones that you do not want to go through. For example, on routers, a lot of times you'll put it through a blacklist, is saying that this IP address range has been attacking us, we're no longer going to want them to go through. And then the whitelist is going to say, I only want to trust this one, everybody else is denied. The benefit of doing that through a router is that a lot of times you cannot have a trusted list if it's going to be like an internet-facing device, because you want everybody to be able to get into the web server. So you may have a deny any and then just basically allow port 80, but port 80 is not going to be restricted by IP address a lot of the times, unless specific ones are attacking you. But if it's an internal router or an internal firewall, then it's definitely a good idea to say that I know that our internal range is 10.10.10.10 or 10.10.10.0/24, and then this one is 10.10.11.0/24. I only want to accept traffic from these two subnets going back and forth. Because a lot of times what will happen is if somebody's trying to spoof traffic, they may put in a packet, get into the network, and they're pretending to be a specific IP address in this range. So on the outside, that's another thing where you could make it to where it's blocked as well, is you know for a fact that these are your two subnets because it's not too advanced of a network. So anything with an internal IP address is instantly blocked from the outside because there's no physical reason that should ever occur. Okay, again in this area, basically just something to memorize. It's subjects is active entity that accesses an object, passive entity that accesses a subject. Access is the flow of data from a subject to an object or vice versa. Access control is the list of trust versus untrust. Access privileges, basically permissions. Access rules, statements specifying the subject's access rights or privileges. And then access path. Again, memorize this. It's going to be the physical, the administrative, and technical. Who can give an example of a, let's say, physical access control? Again, give me lock, fence, man trap, CCTV. It's definitely a good one. What kind of a control outside of physical is it going to be? What characteristic of an access control is a CCTV? Detective, and then also what other kind? Preventative. A lot of people actually have fake CCTVs as well. They'll have one camera that's real, and they'll have 3 other cameras that are fake or turned off. They may even have it to where there's an LED light on the fake ones as well, so people will see that and think it's always recording when it's not recording. So a lot of times people put in way too many cameras, and they're actually just watching the one. The primary ones you're probably going to see are going to be preventative, detective, and corrective. If you do see the others, then it's definitely good to know the differences between them. But it's usually, you have the 6 options, which are preventative, detective, and corrective, and then they will fit inside of either physical, technical, or administrative. And for example, some of the procedures, of course, would probably be detective in a specific area to where you have certain things that you're supposed to do and look for or document. And then the majority of them, like your NDA, in that aspect, if they're just doing the top 3, are going to be preventative. Does everybody understand what an NDA is? Non-disclosure. Basically makes it to where chances are, if they're going to be stealing trade secrets or specific information anyway, they're going to do it. But it's there to keep the honest person honest is another layer, and also gives you, as far as you do care and due diligence, you're going through the proper paperwork to say that they're not supposed to. Because if you don't say that they're not supposed to, and if they do, there's nothing much you can do about it.
Would you consider that administrative deterrent? I
If that's an option, it is administrative. If you just have the 3, then it'd be administrative preventative. But again, that is supposed to be a deterrent. And then on a technicality, it could be if you have it to where you can sue, there could be a portion of corrective in there as well, as far as compensation. But because I know a lot of states, they have, for example, non-compete clauses. And some states have it to where non-compete clause doesn't mean anything because there's not a big enough job market to do anything about it. So a corporation may have somebody sign for it, but when it comes down to it, is the person can still open up an entity doing the same thing across the street. So again, depending on the jurisdiction. But yeah, definitely know the difference between these main 3 and any one of, especially the top 3, are going to be able to deal with the previous 3. If you do have the options for the bottom 3, it's good to know the difference between the 3 or 6. Okay, on this one, definitely beat into your memory the difference between something you know, something you have, and something you are. It's going to be a huge issue. This two-factor authentication is having 2 of the 3. And it's sometimes not a bad idea to have 3 of the 3, but it may not be cost effective. Okay, this right here again, the need to know, it's usually the 3rd variable. So once you have the access rights, you're authenticated in the system, you're authorized to do specific items, then you have a specific classification level or specific security level for your individual person or user. So what ends up happening is then each individual item is going to have their security label. Security label should be no more than what your classification level is for your access capability. But then the 3rd variable is the need to know. So even though you may have the rights to be able to access it, if you don't have the need to know, then it's going to be sandboxed away from you, or it should be. Again, least privilege, this is going to permeate throughout the whole test, is that you want the least privilege. Is that whenever anything fails, you want it at the lowest possible failure rate or lowest possible privilege rate, and that every user, whenever you log them onto a system, or if they change from one job to the other job, if it's at for example, a higher access level, of course, give them those type of rights. But if it's a lower access level, you want to take away all the rights they had previously. Okay, biometrics. Again, this is something to burn into your brain. Type 1 error rate, the FRR, or false rejection rate. There's type 2 error rate, which is false acceptance rate. You need to know both names for both error rates. And then there's the crossover error rate. And the crossover error rate is when the FRR crosses over the FAR. And the truth about biometrics as far as the viability of it is whenever that crossover error rate is at the lowest point. And that's the number that's important for how well the biometrics is working. In the real world, sometimes you may come across where that number is not the most important number, but especially as far as like commercial entities and ISC² is concerned, the or the crossover error rate is the big one. Definitely know the different types of biometrics that are available. And one thing to keep in mind for the CISSP test, it does take a long process to get new questions onto the test because you have your JTAs, or basically have it to where people go in and evolve the test. If specific technologies are no longer used, sometimes they may take that out or whatnot. So that standard gets set to a certain level. And then they have the good old question writing workshops. And this is something that I would definitely suggest anybody that does not teach, because once you do the question writing workshop, you're no longer available to teach CISSP or whatever, like ISSAP, MP, or EP. But if you want to keep your CPEs up to date, those count for CPEs as well. So they fly out to an area, you go through the writing, and that usually takes, say, 2 to 3 days. And then it goes to the different committees, and then by the time that question finally gets into there and vetted out, it may be a year, year and a half later. So some of the questions on here are, I don't want to say are going to be outdated or old, but if a technology came out, let's say 2-3 months ago, or even 6 months ago, it's more likely not going to be on the test. So if things have changed, like with the WPA and how they're able to crack the outside part of the encryption already within an air crack, that is not going to be on the test. So WPA is by far better than WEP.
If I take the next year, the test next year at this time, chances are good it might be on the test.
There's a possibility, but they want you to know that WPA is going to be better than WEP because the algorithm's better. But there's the possibility.
I'll just have to come back and take the review.
Well, you'll just pass it the first time.
Well, I can't even take it for a year and 2 months.
That's true.
So I'll just come back and take the review next year.
Sounds good. Okay, password characteristics. Again, they want you to know that this is the least secure because it's relatively short, it's relatively small, and again, things are only as secure as the way that you protect things. For example, like if your key is on your system, if you're not protecting your system, if it gets stolen, that's an issue. But with passwords, a lot of people write them down, so the key storage or the password storage in that aspect is very insecure. And if you try to use Pig Latin, that can easily be deciphered as well. And that's not an encryption scheme, that would be an encoding scheme. So we'll definitely cover that in a future lab or future slide. Okay, again, best practices. Clipping is definitely a very important one to know about. That's basically the 3 strikes you're out rule, or whatever strikes you want to put onto there. And then auditing. Whenever you have any sort of accountability, you always want to be auditing. For example, if somebody logs in with username and password, not only have the time, date, but where the system they logged in from. Because this can basically have to where if they break into an outside computer or if they do anything illegal or potentially in violation of the security policy, which in theory, anything illegal should be violating the corporate security policy, but there's the possibility it doesn't. It should be accountable for is that that person did or did not do it from the system that they're at. Okay, definitely know the difference between dictionary, brute force, and hybrid attacks. Dictionary, you have your long list of dictionary words or whatnot that you're going to go through. Brute force is you're going to do all possible tries within the subset that you're given it. And then your hybrid attack. Your hybrid attack is going to grab your dictionary and then add random characters at the back of the word, beginning of the word, or change random characters throughout. Some of the hybrids attacks will also do, for example, like uppercase, lowercase changes to where they'd have a specific password and then they'd have it all lowercase, they'd have it all uppercase, then they'd have the first character uppercase, the rest lowercase, and so forth. So it's kind of a, again, the hybrid attack is a variable between brute force and dictionary, but using dictionary words. You know what cognitive passes are? Cognitive passwords are going to be something you know, but it's supposed to be something personalized for what you know. How about CAPTCHA? Does anybody know what that is? A CAPTCHA image. A lot of sites will use this to basically try to defeat people that are brute forcing or are spamming or making accounts where they shouldn't be, or automated tools, utilities. It's basically a picture that has specific words or letters on it. And then you're supposed to read these words or letters, which are usually all meshed or jumbled up, so it's hard to read. And basically that's a CAPTCHA image. And that's designed specifically to bypass some of the brute force attacks or guessing attacks. One thing that I have seen, there was this group that was out there that had this program. And this program would do specific things and basically entice the user to continue to look at the image and then type in what they saw in the image. And then it would get stored in a database and they get sent back to the hacker organization. And then usually after about 8 or 10 tries, the person realized what they wanted to happen with the program isn't going to happen, so then they'd give up. But still, you'd get about 8 to 10 tries of CAPTCHA. So then what they'd end up doing is they'd get a signature of what that file or that image was, and so every time they saw it, that's the first thing that they would try, is what was in their database. So one-time passwords, definitely know what that is. A synchronous token. A synchronous token is going to be your standalone token. It's not going to be communicating back and forth with the server. A lot of times you'll have it on a specific device that's not on a USB stick. And it, like for example, if it's a timing feature, it's going to have the same timing algorithm or timing mechanism inside the device as it does on the server. So, but again, no packets are going to be going back and forth from server to client. asynchronous, they will be. So you have your challenge response, and basically what ends up happening is your token communicates back and forth with the server and then generates the password or the token that you need to put in with your authentication. And it's usually going to be your username, password, and potentially this token that was generated, or one-time pass. Encrypted AFRIC key, passphrase, just a big password. You do need to know the difference, though, between passphrase and password. You do need to know the weakness in memory cards and when to use a memory card versus a smart card. Smart card's usually going to have a computer chip on it, so it's going to be technological. With the memory card, it's just going to be your good old, for example, magnetic reader or potentially even barcode. Okay, know what Kerberos is? And know that basically deals with the KDC. So whenever a system is trying to get information from the Kerberos server to see if it can communicate, it does the authentication phase. As long as it's authenticated, then it goes through the ticket granting service, or basically it just says, okay, now that I am who I say I am, you believe me now, do I have rights to access the device? And what is the biggest issue with Kerberos as far as denial of service attack goes? If you're using a Kerberos system, what was that? Yep, single point of failure. So if you are using a Kerberos system, if it goes down, then basically your network comes to a halt. Okay, SESME, or Sesame, if you want to pronounce it. You definitely need to know this as well. You may come across that. For example, like SEC, it's an encryption algorithm used for credit card transactions. It's not really used anymore. It's basically just trivia as well. But this right here, you need to know that's the European standard. Again, going back to yesterday, definitely need to know the difference between MAC, DAC, and RBAC. DAC is discretionary access control, which is usually going to be your lower level security. You have mandatory access control, which is going to be at TSEC B and higher. And then role-based access control, also called non-discretionary access control. So you may see it as either RBAC or non-discretionary. So just as a forewarning. Okay, another primary difference. DAC is going to use access control lists, and then MAC is going to use security labels. Again, with the mandatory access control within the security labels, you can have the need to know, which then goes through caveats in the system. So the primary thing is that there's an access control, which is basically just a database, as opposed to the individual security labels on each item. Then, of course, role-based is per role as opposed to per individual. Radius, basically know the information behind it is the remote authentication dial-in user service. It uses the authentication, authorization, and auditing protocol. And same thing with its future diameter. TACAX is going to be your Cisco proprietary, or TACAX Plus. And diameter, of course, is the newer version, or the improved radius, which is still going to do the authentication and auditing.
How long has diameter been out? I haven't heard about this. First time I heard about it.
I'm not sure how long it's been out, but you can definitely check on that. But
everybody's pretty much using TACAX or radius.
Yeah, I know the majority of environments that, especially I've been in, are TACAX.
Yeah, well, that same here. Most of the environments I dealt with are using TACAX.
Yeah, so yeah, definitely check that out for you. Also know the difference between centralized and decentralized. I know this is one of the areas where when you hear it, kind of self-explanatory as far as decentralized, as you don't have all the user authentication in one area, it's going to be all over the place. And then centralized would be your good old Active Directory server or anything like that, to where when you authenticate through the system, you're now authenticated through everywhere else. Or you have a stored individual. The problem behind that, again, is then you could potentially have a single point of failure. So if the system or your centralized environment dies or is compromised or is blocked off from the rest of the network, then the local or remote environments may not be able to work. So that's why a lot of people, again, will go hybrid. So you may come across scenarios like that as well, but definitely know the difference between centralized and decentralized and when and why you may use a hybrid. So I know a lot of people will have it to where laptops, for example, you can log into the domain when you're physically on site, but then you can log in locally to the device when you're on or basically on the road or whatnot. Okay, everybody comfortable with IDSs? Basically, they have a signature-based and a behavioral-based. You're probably going to see the term behavioral-based, but heuristics is another term for it. You may see as well. Okay, padded cell, basically just historical thing to know as far as the name. This is primarily, though, within software. So when software sees the attack, it then sandboxes it and then tries to make the attacker think that everything they're doing is actually working, but is preventing anything from what they do from affecting the system. Okay, basically just the vulnerability life cycle. Security researcher finds it, or a hacker group finds it or whatnot. The vendor then sees it. What they try to do is then make a patch or hotfix. They release the patch or hotfix, and then an advisory comes out. So that's the biggest issue is that when bugs are found, if through the Responsible Disclosure Act, or not act, but acting responsibly, is that a security researcher would find a bug, tell the vendor communicates back to the security researcher saying that yes, we've got your information, we're testing your information, give us a minute, and then maybe a day later they say, yes, what you found actually is a problem, give us 30 days to fix it, and before you release the information. And then it goes back to, that's when they give out the patches, the advisory, and then the security researcher then sends out the white papers saying that this is why it was vulnerable, this is how to exploit it, and so forth. With the full disclosure, it goes even one step further, and source code is released to the public. And a lot of times in the full disclosure, the vendor may or may not be notified, but a lot of times they're no longer being notified. Okay, in this area, I hate to say it, but basically it's just steps you need to memorize. Basically you're designing it, and then you get all the specific items that are going to be required. And then you go through the design review. Once you know that everything's supposed to be there, you want to make sure that everything on both sides is agreed upon, such as from the person doing the application to the actual client. The code review walkthrough. So once the code's being developed, you want to make sure that since the specs, the scope have already been designated, that you're sticking to the scope. Test review. So this is going to be your white box testing. And then as soon as the beta code is released, that's when ends up the gray box testing happens. It's compiled, it's given to a group, and then they basically try to hammer the code, try to break the code, and then whenever they get errors or whatnot or security issues, then it's then again released back to the coding development team. CNA process, certification and accreditation. Again, the certification is going to be when your baseline or security baseline is met, then it's certified by a third party, and then what ends up happening is the documents that have been gone through for both your baseline and whatnot is then signed by the DAA, which then it becomes accredited. The DAA is going to be the owner of the system, which could be the CEO, CIO, CISO, CSO, so forth. The difference between a CISO and a CSO is that the CISO is the Chief Information Security Officer, the CSO is the Chief Security Officer, which may or may not be either physical or information security. So that's one of the issues with the CISO. It's almost always going to be IT background or have some sort of information security background. A CSO, it can go either way. It could be the physical security individual that made it to the CSO level, or the IT guy making it up to the security level. Okay, maintenance, going back to the CNA process. Again, once you've been accredited, and that's after the certification, you have to do your either quarterly, yearly, or whatever maintenance contract that you have, and then ensure that your certification is still up to par. Okay, life cycle models. Again, memorize. It's going to be one of the scenarios that you have your waterfall model, and when you go to the next step down, if what you go to does not mesh up with where you were, you have to go back and basically change things. Again, back, for example, the software requirements, if you go to the preliminary design, then find out that it doesn't mesh back with the software requirements, you may have to change either the technologies or the coding that you're going to be dealing with in the future. Same thing with testing. Once you find things within the test that are failing or breaking or there's security concerns, you have to go back to the code and then debug step. So definitely know the waterfall and then the spiral cycle. And the spiral cycle, and then like I mentioned before, I've seen dual spiral cycles occur as well. Basically just do leapfrog within the spiral cycle. Okay, CMM, memorize. Because outside the CISSP, there's a lot of instances you probably will see this in the real world as well. As far as you're going to see the level 1, initial, repeatable, 2, defined is going to be 3, managed is going to be 4, optimized is going to be 5. A lot of organizations try to hit managed whenever they go through the CMM or the CMMI. Some organizations even try outside and above and beyond their software, try to have that same principle within the rest of their systems or organization. Then there's also the IA-CMM, which is going to be the same type of numbering scheme, initial all the way through optimized. The IA-CMM is probably not going to be on the test, but you may come across that in a real-world scenario. Okay, protection rings. Definitely a very important concept, especially on the CISSP. Is the kernel level is going to be 0, and you want to have as many rings as possible between the kernel level and the user level. A lot of operating systems only have 2, maybe 3 rings. And if your user environment is touching the kernel environment, it makes it more, not acceptable, but more feasible for one to influence the other. Okay, viruses are pieces of software that usually do very bad things. Sometimes are basically benign type of transactions, but only live on other files or whatnot. A lot of times you'll see worms that are also benign. They'll transfer, and their whole goal in life is not to destroy the system, but is to infect as many systems as possible before it actually gets shut down. Okay, yeah, the biggest thing to know is that viruses do not spread by themselves. They have to have a host. Worms self-propagate. Logic bombs or time bombs as well basically have some sort of event that triggers execution, and a lot of times you'll see the logic bomb with privileged access, meaning that disgruntled employees can put these on a system. So these are, the logic bombs are usually the very dangerous ones, and especially it's a good reason why you'd want to vet people's code whenever you're letting people go, especially if they're developers or whatnot, because you're looking for the back doors that they put in there, which are going to be your maintenance hooks, and then potential logic bombs, because there's always the possibility that, for example, they're looking for when records in your database hit, say, 10,000 users, and you're at 9,980 users, that they know that you hire, let's say, 20 people every 6-month period, that that's going to actually kill the code or delete the database. So you always want to have your code vetted, even if it's written by entrusted employees. That's one of the things that I've seen, unfortunately, in many, many scenarios, is to where they would implicitly trust their programmers or the coders, so they would give them specific projects, and that individual writes all the code for that specific project, and then when they leave, they basically just do a handoff of all the code, or they can't find anybody that writes that style or writes that way, and that code's still in production environment, but then it never gets inherited by anybody. Somebody else ends up writing their own code and then either replacing it or running it side by side with the old code. But definitely vet people's code. Then Trojan can either be attached to a real program or pretends to be a real program. But again, it's tricking the user into opening up a backdoor into the system. So this Trojan horse can have a payload as well. And that's the thing with a lot of the malware or the malicious software, is sometimes they are both worms and Trojans or backdoors or whatnot. They're multifunctional applications.